Hi, I'm Cullen, and welcome back to Networking Fundamentals. We're about to start with Module 3, Defining Networks with the OSI Model. Do a quick overview of our agenda here. We're going to cover two different objectives today. Objective 3.1, understand the OSI model. Talk about the different layers in this reference model, specifically the communications subnetwork, and then also its upper layers as well. We're splitting it into two halves. We're going to also review the TCP/IP model later in our presentation. Okay, so don't hold it against me that we're not going to go directly to that. But we will move on to 2.1, which also requires us to understand switches, right? Layer 2 switching and layer 3 switching. All of this layer discussion will make a lot more sense after we review the layers of the OSI model. And that's why we're going to review these two objectives together. All right, so without further ado, let's talk about the layers of the OSI model. Standards are sets of rules that ensure hardware and software released from different companies work together. They are the backbone of the internet, not the actual backbone of the internet, because there is something that helps us send data at super fast speeds called the backbone, but they provide the infrastructure really in which we're able to develop software and hardware that works together. There are a few different organizations that coordinate these standards. You may have already heard of me reference a couple. We have the International Electrical and Electronics Engineers. They focus on electrical and electronics fields. You have the International Organization for Standardization, which is called ISO. That's not actually an acronym. That's actually their name is ISO. So keep that in mind. It's not a spelling error on my behalf. I strongly recommend that you take some time to go ahead and Bing each of these organizations and learn what they do, okay? So you're commonly going to hear standards referenced in the same breath as protocols, okay? Protocols and standards, a little bit different. A protocol is a clearly defined rule and procedure that allows different manufacturers to create hardware and software that work together at a specific layer, right? So what are layers? Well, layers make up the OSI model. The OSI model is just a means of simplifying the complicated processes that occur during networking. So we talked about how data was transferred in a previous module, and this model allows us to follow along with that process and understand which protocols belong at which layer and sort of figure out what's going on, right? What's also cool about the OSI model is that if we design any kind of software or hardware, we can pick and choose which protocols we want to utilize in order to accomplish specific tasks. And because it may be, it doesn't matter. Let me rephrase. The protocols that we choose have no impact on the other layers, right? So if we go back to the slide here and you take a quick look, and let's say that I'm designing something for the presentation layer, the protocols that I use on the presentation layer have no effect on layer 5 or layer 7 or anything else. It's completely modular. So I can trust that layer 5, 4, 3, 2, and 1 are all going to do their intended jobs. Really, really cool stuff, and I wish we had more time to detail it. It could definitely be its own course. So let's talk about how the layers function. So if we're at this computer right here, when we send data to this computer over here, it doesn't just happen automagically, right? It's going to start by being created in an application, and it's going to walk down through each of these layers and then go all the way across in a bit format, right, in binary, zeros and ones, and it's going to come back up through that same process once it reaches its destination. It's just really cool to learn how this stuff works. And at each layer, there's a different type of protocol data unit, right? So, or a PDU. So you've got data is just called data at the application, presentation, and session layer. And then at the transport layer, data is broken into segments, which you've heard me reference previously. At the network layer, that segment turns into a packet because additional information is added. And then ultimately at the data link layer, the packet becomes a frame. And then at the physical layer, that frame is translated into bits and then transferred across the network. All right, let's go back to the presentation. Let's talk about the first three layers, the communications subnetwork. The communications subnetwork is made up of the physical layer, the data link layer, and also the network layer. So this is the bottom. It's the seedy underworld that makes up the internet, if you will. Layer 1, the physical layer, it just defines the electrical medium for data transfer, right? So not necessarily an electrical medium, but a physical medium, right? Physical layer components, you've got cables, jacks, patch panels, punch blocks, hubs, MAUs. Some of these things you might be like, I have no idea what this guy's talking about, and that's okay. Go ahead and take a quick second to bing them. Just for the sake of time, we don't have enough to cover every little tiny detail. So keep that in mind if you hear me say something that doesn't make a lot of sense. Just take some initiative and bing it. You'll be happier for it, okay? Physical layer concepts, we've talked about topologies. We talked about serial data transfer. We're going to touch on baseband versus broadband, and we will talk about analog and digital encoding here in a while too. Once again, the unit of measurement here at the physical layer is bits. Bits, as they move up, oh, sorry, different slide. Ethernet standards. We just talked about these really quickly here. Ethernet standards, it's a local area network standard like we mentioned in our previous modules. Defines a communication method for high-speed data exchange among devices. And you're commonly going to see that, if we look back at the presentation here, you're commonly going to see that the technologies here are referenced in this particular format, 100 base T as an example. 100 is for 100 megabytes per second. If it was in gigabytes, it would be 100 with a capital G, right? Base is short for baseband, which is a technology that we can detail a little bit later. And then T stands for twisted pair cabling. So we know that the medium that's being used is just copper wire. Okay. Keep that in mind. All right. So now going back to talking about bits, as bits move up the stack, to layer 2, from layer 1 to layer 2, they're going to be turned into or rather, they're going to become frames. The data link layer is going to establish, maintain, and decide how transfer is accomplished over a physical layer. So it's going to prepare your data for transmission on that physical layer. Data link layer components are your network interface cards, bridges, which are technology that we'll talk about a little bit later as well. And the unit of measurement here is frames. The data link layer is responsible for making sure that data is transferred properly and that there aren't any errors in it that occurred during transmission, right? So that when the computer on the other side or the device on the other side receives that data, that it is whole and prepared to be turned into the beautiful files that we see on screen. All right. Something that's really, really important here at the data link layer, and we talked about this as a physical address earlier, is MAC addresses. MAC is short for Media Access Control, and every single network adapter on an Ethernet network has a MAC address. A MAC address is very, very similar to your fingerprint, right? They're unique identifiers. So this is my finger, right? All of us have fingerprints, and they identify us as unique individuals. Network cards, very similar in that regard. They have MAC addresses, which identify them as unique devices. Okay? A MAC address, so we take a look back at the screen here, it is 6 octets in length, written in hexadecimal format. And so you might be like, what does that mean? Hexadecimal, it includes 0 through 9, and then A through F. So you have 16 different characters there if you include 0 through 9 and A through F. And notice here, there are just 6 octets. Each pair of hexadecimal characters represents a byte, right? So that's 8 bits. But this first portion of a MAC address typically references the manufacturer, right? And then the second portion is going to be unique to the device. So cool bit of information. And remember that sometimes we'll call MAC addresses physical addresses as well. All right, so now that we've talked about the first two layers, let's talk about layer 2 switching. So how do the devices that operate on networks, how do they function within these two layers? So first off, let's start by talking about what a switch is. Okay, a switch is a central connecting device like we had detailed earlier. Switches use MAC addresses to establish point-to-point connections. And what this means is that we make sure that if we have device A and it wants to send data to device B, it can send it directly to that device, right? It doesn't have to broadcast all that information to all other devices that happen to be connected to a switch. If you take a look at this switch example down here, you see a lot of different ports, right? So there are a lot of devices that can connect to a switch. It's really important for security's sake that if you want to establish point-to-point communication, that you actually are able to do that, and switches allow you to do so, okay? Hosts, of course, they connect to switches by plugging Ethernet cables, or rather you can connect a host to a switch by plugging an Ethernet cable into the host and to a switch port. Okay. Another cool thing to note is that every single port on a switch has its own, or it's associated with its own specific MAC address, right? So the device that's connected to it, that port on a switch is associated with the MAC address of the device that's connected to it. Okay. All right, so we talked about what a switch is, but what's a layer 2 switch specifically? A layer 2 switch, just the most common type of switch that's used in a local area network. And like I mentioned previously, they direct frames on a LAN based on physical addresses or MAC addresses. Each port of a switch is mapped to a MAC address of the device that's connected. So a little bit redundant there, but pretty good information, right? So you might have two computers. Maybe we have a laptop down here that features that MAC address of 23.5C, F7, and so on. This port right here is then going to be dedicated to that MAC address. So these guys function, layer 2 switches, they function just simply using the MAC address to dictate where information is going to go. So if I have this example here, actually, let me back up just a touch. Let's say that this computer here wants to send information directly here. And we'll go ahead and make it so that this laptop down at the bottom is directly connected to a port that's associated with this laptop's MAC address. And so that's how information is going to end up at its proper location. The switch just uses that MAC address information to direct the data to its destination. Oh, I knew that something was funny, and here you have MAC addresses that just popped up. My apologies, I didn't realize that those were going to transition, guys. We had talked about virtual LANs as well, and I just want to briefly touch on this. Layer 2 switches, they allow for virtual LAN implementation, okay? And there's a standard here that's involved to support VLANs, it's 802.1q. I've highlighted it so that you know that you should go and do a quick Bing search in order to learn a little bit more about that. But as I mentioned in a previous module, what happens is that as data frames are sent, tags are added so that they're only directed to computers on their specific VLAN. All right, let's keep on checking. So you might be wondering, like, how do these switches remember MAC addresses? Well, switches have memory that's dedicated to remembering these addresses. Switches are just going to map the MAC addresses of connected computers to their ports in something called a content addressable memory table. All right, so you can see, I guess a basic example here. It's not a table as we think of it, right? Because it's really simplified data. But a sample CAM table is there. And note that if you have port 1, you're going to see that this MAC address right there is associated with it. and so on. Okay. The memory of a CAM table, though, know that that memory is limited. And so there's communication that occurs between a laptop or a PC and the switch that it happens to be connected to, where you actually send that each device is going to send its MAC address onto a switch. People can take advantage of the fact that switches store MAC addresses in their memory by constantly sending MAC addresses and flooding that switch and making it difficult for it to be able to store that information. And then that can render the switch inoperable. So keep that in mind. All right, so layer 3 switching is a little bit different, okay? Layer 3 is the network layer. Right? It controls the operations of routing and switching. It translates logical addresses or names to physical addresses or vice versa. So if you're receiving data, you're going to go from a physical address into a logical address. A major protocol that we're going to learn a lot about today, called the Internet Protocol, is a network layer protocol. Also IP is typically what it's referred to as. And devices that work at the network layer are routers, and then layer 3 switches, which can also be called IP switches. Okay. There are a few different network layer components. You got IP addresses and also subnets, which we featured in our last module. And the unit of measurement here is called a packet. Layer 3 switches are different from layer 2 switches because they direct data using IP addresses instead of MAC addresses. Okay, so they forward packets instead of frames. They can perform all of the same functions as routers, but they're not routers. Okay, the benefit here in using a layer 3 switch versus a router is that they can actually forward packets faster than routers. And detailing how this is done is a little bit beyond the scope of this course. But if you're interested, once again, take that initiative and go ahead and bing it, right? All right. Let's go ahead and move on to the upper OSI layers. Layer 4 is a transport layer. This is my favorite layer. I don't know why, but I always geek out whenever I get a chance to teach this layer in class. The transport layer ensures that the messages are delivered error-free, in sequence, and with no loss. And I think that that's such a cool thing, okay? There are a few different protocols that work at this layer. They segment messages, right? Those protocols. They ensure correct reassembly, like we mentioned previously, and they also do something called message acknowledgement. This is sort of like a certified mail. So like if you send grandma a box of chocolates and you really want to make sure that she gets those, she's got to sign for them upon delivery, and that's what message acknowledgement is. We'll detail that here in a second. And it's also responsible for message traffic control. Within the transport layer, there are both connection-oriented and connection-less protocols, and we'll detail those here in just a moment. The unit of measurement used, segments or messages. All right, so let's take a look at the screen here. Take a look at the PowerPoint presentation. Connection-oriented communications. They require that both devices involved in communication establish a logical connection. So it's like, hello, I'm a PC. Hello, I'm a server. Right, so they establish communication. This is considered sort of I guess you would call it a reliable network service, because if you have established communication, if you're doing this in person with two people, you would know the other person, you would know who they are, and all of a sudden they become more reliable. And so what's going to happen is that if I'm the PC and you're the server, I'm going to say to you, I'm going to send you something important, and you're going to acknowledge that and say, okay, I'll let you know when I get it, right? So if that important item or that important data is sent by a PC to a server and it doesn't reach the server, then all of a sudden the server says, hey, resend that data. And of course the PC will. All right, so let's talk about connectionless communications. End-to-end connection, not necessary at all. Every packet that's sent has a destination address in the header. And really all that happens with connectionless communication is that packets are just sent like one after the other. There's no guarantee that that they'll reach their destination, and no guarantee that you know to resend them or that your device knows to resend them if they don't reach their destination. So a little bit different example where a PC is saying, I'm sending something, and of course you've got a server over here that's just sleeping at the wheel. So we're gonna send packets in a stream, and there's absolutely no guarantee that they have been received. So connection-based protocols, we've got two that we can detail. Actually, there's one connection-based and then one that's connection-less. The connection-based protocol is TCP, or the Transmission Control Protocol. It's a reliable byte stream service. You're gonna see this being used and leveraged by, maybe email applications, other protocols like FTP, where you need to download an entire file guaranteed. In contrast to UDP, it's connection-less, it's unreliable. You're probably gonna see this if you're streaming a movie or streaming some kind of audio. Of course, these technologies, there are a couple different variants. And so if you're really curious if YouTube or if Spotify or something along those lines, which protocol they're using, go ahead and take some time to look it up. That's a really interesting way to learn about these transport layer protocols. All right, so like I mentioned there, if you're web browsing, you're probably going to be using TCP. If you're streaming media, probably going to be using UDP. TCP, it's only used for one-to-one communication, right? And UDP can often be used for one-to-many communication. So for broadcast or multicast. Broadcast, of course, we covered that. It's when maybe your device wants to send communication to all of the devices that are on its local area network, and then multicast is if you would send it to just a few select devices on a local area network. All right. Another construct of the TCP layer or at layer 4, the transport layer, is ports. Okay. Ports are used for sending and receiving data transmission, right? It's all that ports are is they're like little doorways that are dedicated to specific programs or specific types of data and protocols. There are a total of 65,536 ports. They're all numbered between 0 and 65,535. That's a lot of ports to remember. All of these guys are defined by IANA, the Internet Assigned Numbers Authority, and I can't imagine having to memorize all those different ports. So thank goodness there's somebody out there who's willing to handle it for us. That being said, there are some common port numbers that you want to make sure you remember. These are definitely going to be tested on the exam. These are extremely, extremely common. So do know FTP, SSH, Telnet, SMTP, DNS. DNS stands for Domain Name System. We'll detail that later. HTTP stands for Hypertext Transfer Protocol. It's in your URL bar in your browser probably right now, or some variant of it is. Just make sure that you take time to really understand these port numbers and do a little bit of research on each of the ones that are listed here, each of the associated protocols that are listed here with those port numbers. All right, so moving on from layer 4, we get to layer 5, which is the session layer. This just manages session establishment. So if you start using an application online, that's a session right there. Right? You log in with your username and password, and you start a session. And when you close out of that application, you end a session. And so this layer is responsible for controlling just the name and address database for the OS. And to do that, we've got a protocol called NetBIOS. It works at this layer. Definitely go ahead and give NetBIOS a quick Bing search and learn a little bit more information about it. All right. Layer 6 is the presentation layer. The presentation layer is responsible for taking data from the sender and then translating it into a format that your operating system can use. So if you're using Windows 8 and about to be using Windows 10, the presentation layer is going to be responsible for helping to prepare the data for rendering on screen. Okay. Here it's also, if you're sending data, it can be responsible for data compression, data encryption. So it's definitely responsible for components of security in terms of data transfer. And there are also something called redirectors that work on this layer. And redirectors, they allow you to, I'm trying to think of the best way to explain it. And here I have it listed as mapped network drives that enable a computer to access file shares on a remote computer. And I guess what I'm getting at is that if you're working for a business or for a school district, you might store your files remotely, and a redirector would be put to use there so that you can access a remote drive through a remote protocol. Okay, we'll detail a couple of those a little bit later. So. All right. Layer 7 is the application layer. This serves as a window for users and application processes to access network services, and this is really where message creation begins. It's really important to note that this layer is not the application itself or any application itself, but this layer represents the protocols that are used or initiated by this layer. Okay. A few of them are FTP, SMTP, Telnet, and also RAS. All right, so just a quick review of the OSI model here. You've got 7 layers. There are some of the key protocols that are featured at each of the layers, and also the different types of devices that are used at each layer. All right, so there's another reference model that we use. It's called the TCP/IP model. It's very similar to the OSI model, but it's composed of only 4 layers. So you've got the application layer, the transport layer, the internet layer, and also the network interface layer. I remember the order of this as a tin. I think of it a tin cup, and I'll try my best to draw one here, right? So if you ever have like a soup can or something like that, this is how I think of it. I think of it in 4 layers. This is kind of silly, so I apologize if my animation's getting in front of the words. But I think of a tin cup with 4 different layers, right? And that, for whatever reason, just helps me remember the order of the TCP/IP model layers. Notice some of the same protocols are listed there, and we'll see in just a second that the TCP/IP model definitely matches up and aligns with the OSI model. The only difference here really is that there are 4 layers instead of 7. And here's how that matchup occurs. So note that in the OSI model, the application layer, the presentation layer, and the session layer, they match up with the application layer and the TCP/IP model. Transport layer, only one that remains the same. The network layer is actually called the internet layer with the TCP/IP model, and then the network access layer is actually referencing the data link layer. The physical layer is entirely skipped altogether in the TCP/IP model. All right, so that's it, ladies and gentlemen. Just a quick recap. We talked about Objective 3.1, understand the OSI models, featuring the layers of the OSI model, more specifically the communications subnetwork, and then the upper OSI layers as well. So we covered layers 1 through 7. And then we had Objective 2.1, understand switches, and we talked about layer 2 switching and layer 3 switching, and the difference between both of those devices, a layer 2 switch and a layer 3 switch. Thank you so much for joining me for this module. I really look forward to the next one. I'll see you again in Module 4.